right, now some of these can be solved by different types of factoring that we haven't even talked about this year. So we're going to do this one consistent way so that you can solve any of these the same method. If you'll notice, we have x to the third minus 3x squared plus x minus 3. What's my highest degree term there? X to the what? Third, which means when we solve this, how many solutions should we have? 3. All right. So what we're going to do first is do the rational root theorem like we talked about on Thursday, where we list all of our possible rational solutions. If you forgot or weren't here, remember we list the factors of our first term, which in this case is just 1, and the factors of our constant term, which is 3. So those two factors would be 1 and 3. And then remember, it is plus or minus one of the factors of the constant divided by the factors of the leading coefficient. So plus or minus 1 divided by 1 is where we start. That's always an option. And then because I don't have any other factors for my leading coefficient, then I move on to that 3. And we do plus or minus 3 over 1. And those are going to be the 4 possible rational solutions to our equation, okay? That doesn't mean that any of them are actually a solution, and that doesn't mean that all of them are solution, but at least those are our possible rational solutions. So if you look at your leading term, the coefficient in front of it, the number, the 1, so the factors of 1 are just 1 and 1, which you only need it once. Does that make sense? And the 3 is the factor of my constant term. Basically the first term and the last term, as long as it's in standard order. Okay, so then the next thing we're going to do is we're going to set this thing up for synthetic division, just like we did Wednesday of last week. I can't remember. Maybe. So we start with the leading coefficient, or the coefficient of the leading term. It's x to the third. It's a positive 1. And then we have a negative 3x squared. And then we have a positive 1x. And then we have a negative 3. I put my little box, or my half of a box there, and we're going to fill that in here in just a couple of minutes. Is everybody okay with how we set that up, coefficients? Because I'm using the coefficients of my terms. There's a 1x to the third, a negative 3x squared, a positive 1x, and a negative 3.
Oh, okay.
Okay. All right, so then we're going to start with the first one. I'm going to start with positive 1, and I'm going to try it. What I'm looking for is, if I do the synthetic division here, I'm looking for this to have a remainder of 0, because we talked about things are factors as long as they have a remainder of 0. So what I want to do is I want to do the synthetic division on this. If it has a remainder of 0, that means that 1 is one of my solutions. If it does not have a remainder of 0, then we're going to have to start over and try again. Okay, so remember what we do is we bring our first term down, and then we multiply and put it under the negative 3. Then we add, and we start over again. We multiply the 1 times the negative 2, and we add, we multiply, and we add. Is my remainder 0 there? No. So that tells me that 1 is not a solution. So what we're going to want to do is we're going to try it again. We're going to try negative 1 this time. If that doesn't work, then we'll try 3 and we'll try negative 3. We're going to go through all of the options for possible rational solutions to be able to find one that has a remainder of 0. You can set it up again. Like I said, sometimes these take up a lot of space, especially if you have to try multiple answers. But we're going to try negative 1. Bring down the first term. We multiply. We add. That's not what that is. Try that again. We multiply. We add. We multiply. Did I get a remainder of 0 that time? Okay, so that means 1's not a solution. Negative 1 is not a solution. So then we're going to try the other 2 possible rational solutions. We're going to try positive 3 first. Again, you can either erase or you can just start over. I'm going to try 3 this time. Does that give me a remainder of 0? It does. Okay. So one of my solutions to this equation is going to be a positive 3. So I'm going to go ahead and write that off to the side somewhere, because when I get my other two, I'll be able to tell you what all 3 answers are. So far, so good? Okay. Then what we do is we take what's left and we write our equation from there. Since we started with an x to the third, when I write this leftover stuff as an equation, it's going to, what's this first one going to be a coefficient of? Not x to the third, but one less than that, so it would be x squared. And then I don't have any x terms, so I don't put anything there because that's a 0, and then we're going to put plus 1. And we want to set that equal to 0 because we're going to end up solving this. Now, the problems that we're going to do today, everything can either be solved by basically taking the square root once you get x squared by itself, or factoring. Tomorrow we'll do some that you have to do like the quadratic formula for to get a little bit further to solve those. But today we're going to keep it to where it's not too terribly difficult once we get here. So if I have the equation x squared plus 1 and I want to solve it, how do I get x squared by itself? Before I do that, I want to take that, yeah. Okay, so I get x squared equals -1. And then now to solve for x, I have to take the square root, yep. And what's the first thing we put when we take the square root? What symbol? Plus or minus, yep. And then how do I reduce the square root of -1? What does the square root of -1 equal? It equals I, right? Which gives me my other two solutions. We found positive 3 was one of our solutions. And then I solved what I had left, the x squared plus 1 equals 0. And I got the other two solutions would be a positive I and a negative I. So when I write my answers, you can either write it out as positive I and negative I, or you can just write it as 3 and then plus or minus I. That is 3 solutions. One of them is a rational solution. The other 2 are imaginary solutions. But either way, we start by listing the possible rational solutions. Then we use our synthetic division and we divide until we find one that is a factor. That means we have a remainder of 0. Then you will have an equation left that you can solve by either factoring or doing like this today, where we subtract or add over something and take the square root. Everybody kind of okay with that? All right, I want you to go ahead and set up number 2 and start working through it till you find one of your possible rational solutions. So again, the very first thing we do is list our possible rational solutions. What are the factors of my leading coefficient? What number's in front of x to the third? 1. So it's just 1. Oops. Try that again. And then for my factors of 6, it's 1, 2, 3, and 6. So then we do plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. There are no other factors of my leading coefficient, so I don't have any fractions, thank goodness, to deal with. And so we're going to set up our synthetic division. 1x to the third, 4x squared, 1x minus 6. And I'm going to start with 1. After we do this and we see if we have a remainder, I'm going to tell you the trick on how to determine if 1 is a factor without having to do your synthetic division. Multiply, add, multiply, add, multiply. And this time we actually get a remainder of 0, right? So 1 is a solution. Now here's the trick. If we take all of our coefficients right here that we put in our synthetic division, if you add all of those together as they are with their signs, so like 1 plus 4 plus 1 plus a negative 6, if that gives you 0, if all of those coefficients cancel out to be 0, then 1 will always be a solution. So that's kind of a trick. You can check that to see and then say, okay, well, I don't need to try 1, or I know 1 is an answer. So if you remember that, if you don't remember that, then you can always do your synthetic division and work it out. What is the equation going to be that I have left with these coefficients? It's going to be 1x squared, okay, because we started with an x to the third, so it's going to be 1 less than that, plus 5x plus 6. That is a trinomial. That is no GCF. Are there numbers that multiply to give me 6 and add to give me 5? What? 3 and 2. Both of my signs are going to be the same, and they're both going to be positive. And then just like we always done with factoring, we just set each one of those equal to 0. And we solve for x. So I get a -3 and a -2. That is also a solution. Did I have the number of solutions I'm supposed to have based on my exponent? Yeah. Does that make a little bit of sense? Say that one more time. No, because we took what we had left right here, the 1, a 5, and a 6. We wrote our equation x squared plus 5x plus 6. We were able to factor that, so we know that we can. You only have to check it to get the first one with your synthetic division. After you get your first one, you're going to have an equation that you can either factor or you have to do the quadratic formula on, with a couple of exceptions, which we're about to do one in just a second. Everybody kind of okay? Go ahead. Oh, yeah. You took the beginning and factored out what they had in common. Hold on. You just did synthetic division until you found them all. That works as long as all of your answers are rational answers. But like on the question number 1 where we had I, you wouldn't be able to find them all that way. But as long as all of your solutions are rational, you can definitely do that. All right, let's take a look at 4. It's a little bit different. I mean, not 4, 3. It's a little bit different. But what I want you to do first is go ahead and list all of your possible rational solutions, and I'll talk to you about why it's different in just a second. Okay, take a minute, go ahead and list. All right, so factors of my leading term are 1. Factors of my constant are 1, 2, 3, 4, 6, and 12. Is that all of them? All right, so we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now, before we start, I want to focus on why this one is slightly different. Is look at your leading coefficient. How many answers are we supposed to have this time? Supposed to have 4. So if you have 4 or higher, you're going to have to do synthetic division multiple times to be able to work down to a quadratic, an x squared, that we can actually solve, okay? So we're going to start our synthetic. First of all, if I do my test, if I'm looking at my coefficients, let's see. Whoops. I have 1, 4, 7, 16, 12. All of those are positive numbers. Is there any way that's going to go to 0? No. So I'm not going to waste my time trying 1 because I know it's not going to work. So I'm going to start with -1. And I'm going to do the synthetic to see if that one works. And it does, doesn't it? Did I do that too fast? Sorry. So I divided it with -1. My remainder is 0. So -1 is going to be a solution. So I'm going to put that out here to the side. So don't forget about it. But if I focus on what I have left, okay, that is an x to the 3rd. And we can't factor an x to the 3rd, right? I mean, technically you could with grouping if it factors, but what we're going to do is we're going to use these numbers, the ones that I just uncovered the highlight for. We're going to use the 1, the 3, the 4, and the 12, and we're going to do synthetic division again, okay? We know that -1 is the solution. We know that 1 is not a solution because we can't, our coefficients in the beginning didn't try it, so there's no need for me to try 1 again. And the only reason I would try -1 is if I go through every other possibility and it's not a solution. Sometimes you'll have the same answer twice. I'm trying not to give you some of those because that's frustrating after you go through all that work. So I'm going to start with +2, and I'm going to try that. And we're going to work it out. If we get a remainder of 0, then that is also a solution. If we don't, then we'll have to pick a different number and try again. Bring down your 1. Multiply 2 times 1. We add. We multiply. We add. That's already way too much, isn't it? So that's 40. That's definitely not going to work. So then I would try -2 and take a minute and see if that works. So we should be doing our synthetic division with -2. Again, we have a total of 4 answers. What we have to do is find 2 of them first to be able to get down to an x squared, a quadratic that we can factor and solve. If I try -2, that also does not work. So keep going. Try +3, try -3. It does. Okay, let's try that then. Bring down the 1. That's -3. That's 0. That's 0. That's 4. That's -12. So that does give me a remainder of 0. So my second rational solution is going to be -3. Now remember, we started with an x to the 4th. We've divided twice. With the first division, sorry, I was trying to draw an arrow, that left us with an x to the 3rd. But when we divide again, what's this one going to be? X what? X squared. So it's going to be 1x squared. I don't have any x's, plus 4. And so now this one looks a lot like question number 1. I just have an x squared and a number. So if I want to solve it, what do I do with that 4? Subtract it, yep. So we get x squared equals -4. Then we take the square root of that. And I put plus or minus first. And then what does the square root of -4 simplify to be? 2i. Okay, so those are going to be my other 2 solutions, along with the -1 and the -3 that we found, for a total of 4 solutions. You can either write it as a +2i and a -2i. I usually just tend to write it as plus or minus, just because it doesn't take up as much space and a little less writing. So my 4 solutions are -1, -3, and then plus or minus 2i. Is everybody okay with that? All right, I want you to completely try number 4. Let's see if we can get all of our solutions. This one is back to an x to the 3rd. Again, we start by listing our factors of our leading term and our constant term. Then we do all of our possible rational solutions. And if I look at my coefficients, let me set it up first. I got a +1x squared, a -2x squared, a -11x, and a +12. If I add all those together, does that zero out? It does. So that tells me that 1 is going to work when I do it. And what I mean by is going to work, it's going to give me a remainder of 0. Okay. So 1 is a solution. And because I started with an x to the 3rd, this is going to be an x squared, so I can go ahead and set it up. I got 1x squared minus 1x minus 12. That will factor. What are the factors of 12 that subtract to give me 1? This means my signs are different. That one goes in front of the bigger number, so -4 and +3. And we set each one of those equal to 0. And the other 2 solutions I get are a -3 and a +4. So in this case, we could have kept doing synthetic division and found all of our answers. But again, you don't know that until you solve it. So I would find your at least one answer and then go through the factoring process to get the others. Okay, because you might waste your time and do all that synthetic division and not be able to find the other solutions. Is everybody okay with that? Now, I want to show you, for instance, on something that could happen when you solve, and just talk to you about how to leave the answer. But if I had this equation, like if I had x squared plus 5 equals 0, or let me scratch that. If I had x squared minus 5 equals 0, what I would do to solve this is I would add my 5 over. But this time when I take the square root, is 5 a perfect square? No. So what I would just leave it as plus or minus the square root of 5. So if you get a radical that doesn't simplify, then just leave it under the radical.